Today we're going to talk about light. Our last part of this unit was talking mostly about sound. Today we're going to talk mostly about light. Light's going to do two things. An object's either going to reflect or absorb. It probably is either going to reflect three things: reflect, absorb, or transmit light. For you to see the object, it must reflect light. It must reflect light for you to see it, but it can also absorb or transmit. The type of matter in the object determines the amount of light it absorbs, reflects, or transmits. We can break things down into three different categories. We can say something is opaque. Okay, an opaque object absorbs and reflects light. No light passes through it. So the wall in my classroom would be an example of something that is opaque. Okay, nothing passes through it. It's just there. It reflects light. Okay, it's white, so it reflects the light, but nothing passes through that. Another example of something being opaque would be the top of your computer. Would be black. Okay, nothing passes through there. The other way we could describe something would be translucent. It allows some light to pass through. Not all of it, but some of it. The biggest example of something translucent would be tracing paper. Okay, you put tracing paper over something to trace something the way it looks like. Okay, it's not real clear, but you can still see the outline of it. And then finally, transparent. Okay, transparent transmits almost all light striking through it. Only a small amount of light is absorbed and reflected. So a very good example of transparent, something that's transparent, would be glass. Most glass is transparent. You can see directly through it. Now, there are sometimes light, based on how it is, does reflect off of it. Some of it is absorbed, but most things go through most light goes through a transparent object, so light goes through it. Now, we can also look at some other things that are transparent, and we can actually maybe look at, say, like a soda. Okay, a soda is Mountain Dew opaque, translucent, or transparent? And the first question you need to ask this: can you see through it? Yes, you can see through Mountain Dew. So that rules out opaque. Okay. Now, you have two things left: translucent and transparent. Okay. Translucent and transparent. Can you see clearly through Mountain Dew, or is it somewhat blurred? Typically, I think most people would say it's somewhat blurred, so it is not transparent. In fact, it would be translucent. Most people would consider transparent being clear. If you can see clearly through it, it is transparent. Okay. If it is, kind of shady, some light passes through it, it is translucent. So like a stained glass window would be translucent also, because light does pass through it. Some of it is absorbed, but some of it does pass through it, so you can see through it. So looking at things that are typically opaque, opaque reflects most things. Okay, most things are opaque, reflect things. We know that from the last unit, the law of reflection states that the angle of incidence equals the angle of reflection. Now, why is this important, you ask? Okay, because everything obeys the law of reflection. Okay, but we can break things down into two different types of reflections. Okay, a regular reflection and a diffuse reflection. Okay, a regular reflection is what you see when you look in your mirror in the morning. I mean, some of you need to look in your mirror a little bit more often. Not going to say any names, Larry Horton, but a regular reflection is a reflection off a smooth surface. Okay, mirrors are very, very smooth. Okay, mirrors are very, very smooth. It bounces back, so you can see the angle of incidence. Angle of reflection is still there, but it bounces back in a way so that you can see it. Okay. To cause a regular reflection, the wavelength of light must be more than the roughness of the surface. No surface is perfectly smooth. There are some pits in it, but to make it to where it is considered a smooth surface is though that surface has to have very, very small, very, very small indentation. If you would look at a piece of paper for example, a piece of paper is rough. We know it's rough because you write on it. You write on a paper due to friction, and the little pits and valleys allow your lead to come off of it. So we know that a paper is not real smooth. We know glass is very smooth. This is why you can't take a piece of paper. This is why you cannot take a pencil and typically write on glass, because it's smooth enough where the tip of the pencil is bigger than the pits and valleys. A diffuse reflection is the type of reflection in which things are scattered. Okay, you can't see your reflection off of a diffuse reflection. Okay, so I can go stand in front of my wall and I can't see my reflection. I know things are reflected there because the only way I can see something is because it reflected it, but I can't see myself off of it because the way it scatters it in all those pits and valleys, it scatters it millions of different ways, so it doesn't come back into focus of my eyes. So diffuse reflections are things that do not give off a clear image, or you don't give off an image at all. A regular reflection is a reflection that gives off a smooth surface like you can see. So we talked also last unit, the index of refraction, okay? The index of, refraction of light. We saw that we put our pencil or a straw in water, it looks like it's bent, okay? We know that happens because of the change in speed, okay? Our brain doesn't process that. But we know it, okay? Our eyes and brain don't process that together, but we know that it is one piece. The greater the change in speed, the more the light will refract. Okay, the greater the change in speed, the more the light will refract. The index of refraction. Someone asked me about, is there a law of refraction? No, there's an index of refraction. Okay, it's the ratio of the speed of light in a vacuum to the speed of light in material. These are known values. People know the index of refraction of water. People know the index of refraction of glass. People know the index of refraction of plastic. You know the index of refraction of everything. Okay. It is known. The larger the index of refraction, the more the light is slowed and the more the light bends, okay? The more the light is slowed and the more the light is bent. The index of refraction is larger in solids and smaller than gases, okay? That's why a prism refracts light, okay? A prism refracts light and you can see the rainbow looking through that. It is more so than in your gas. Gases typically have a very small index of refraction. And we kind of know this because we don't ever really see any refraction in the air. Okay, we don't really see any refractions in the air very often. A prism is what causes a refraction. It separates light into a beam. White light is all light. We'll talk about that again later this unit. White light is all colors of light, but a prism separates white light into its different colors. That's the color of the rainbow. Okay, water can act as a prism whenever it's raining and sunny. Whenever it's raining and sunny, and it acts as a prism and it separates them into the colors of the rainbow. It used to be Roy G. Biv, red, orange, yellow, blue, or red, orange, yellow, green, blue, indigo, violet. Indigo has been Plutoed. It is no longer a color of the rainbow. So it's now Roy G. Biv, no I, no indigo, red, orange, yellow, green, blue, violet. Those are in terms of increasing wavelength, okay? Those are in terms of increasing wavelength. So that's what a prism does. It separates things into those colors. A mirage is a type of prism. A mirage is an image of a distant object produced by the refraction of light through different layers of density. So when we're talking about mirages, we're talking a lot of times about in air, okay, because the air has the different densities. Mirages result when the air at ground level is much cooler or warmer than the air above. Our biggest example of mirage is you're driving down a blacktop road or the interstate in the summertime, and it looks like there's either oil or water on the road. That is because that light has changed speeds and different densities. Okay, it's hotter closer to the ground, so it looks like it's traveling at a different speed. It looks like there's water there. We know there's no water on the road. We know there's no oil on the road, but our brain thinks that there is, or our eyes think that there are. So a mirage are things that you see that aren't really there. Okay, a mirror. Okay, a mirror is a flat, smooth surface is a plane mirror. Okay, so your mirror probably in your house that you use to get ready, in a tall flat mirror, is a plane mirror. They produce a virtual upright image. A virtual upright image. Question of that is, what's a virtual image? Okay, a virtual image doesn't mean it's a fake image. Okay, but a virtual image is the image formed at the position where the paths of the principal rays cross when projected backwards. Okay, the image appears to be behind the mirror. A lot of images we see are virtual images, okay? A lot of images we see are virtual images. The rays don't actually cross, but if you trace them backwards, they appear for coming behind the mirror. If you want to see yourself, there need to be two things that happen. To see anything, two things have to happen. Light has to reflect, light waves have to reflect, and they have to reflect into your eyes. So to see yourself in a mirror, the light waves are reflected off of you, because to be able to see you, it has to reflect off of you. And then for you to see yourself, they have to be reflected off the mirror, in a way, in a regular reflection, in a way that the focal point, we're going to come back to that again here tomorrow, where the focal point is uh, where the focal point is at your eyes, okay? Not where they're spreading out. It needs to be a regular reflection. And a diffuse reflection, you can't see this because when the waves are reflected off the mirror, they're reflected in different ways. They don't all come together. So a flat, smooth mirror is a plane mirror. A convex mirror and concave mirrors, okay? Concave mirrors, the concave mirror is the surface of the mirror is curved inwards, okay? It's curved inwards. Caves go in. And remember, mirrors reflect. Mirrors reflect. A concave mirror is a mirror that curves inward, okay? The image formed by a concave mirror depends on the location, the focal point. In general, a makeup mirror is a concave mirror. So people who have a makeup mirror, what it does is it enlarges it typically. We typically have it between 1 and 2 focal points, okay? But even if it's closer than 1 focal length, it still produced a larger image. So I remember when my brother was younger and we were little, he can't see very well and he wore glasses. He tried to get contacts one time, but he couldn't see well enough to put his contacts in. So what my mother did, my mother bought him a makeup mirror, and the makeup mirror made it larger. Concave mirrors make things larger. A convex mirror produces a virtual upright. Remember, virtual comes from behind. Okay, virtual is where these light rays do not actually cross, but if you project them backwards, they would cross. Okay, a real image, back that up. A real image, we had that on the thing, is where they do cross, but where the rays actually do cross at a point. So a convex mirror produces a virtual upright and smaller image. A virtual upright and smaller image. So in a vehicle, I don't know if anybody ever pays any attention to a passenger in a vehicle. On the passenger side, it says objects in the mirror may be closer than they appear. What that's telling you is that's a convex mirror. It's a convex mirror because the image is actually smaller than what it really is. Some cars have that as their passenger mirror. Other places where convex mirrors are used would be like in stores. You see like the globe, the round thing in the corner, and it makes things smaller, but it allows you to see more. It makes it smaller, but they can see around the corner and see things like that. So a concave mirror would be like looking at the inside of a spoon. Okay, if you look at your reflection on the inside of a spoon. A convex mirror would be turning the spoon around backwards and looking through it. Thank you.